Let us start this podcast, Agri Podcast by Chetan Dabke. How it is impacting the agriculture future of India. We have someone very wonderful, a young and energetic guy.
I was asked to pursue a government job.
Okay.
So just like I happened to visit places where farming was actually a major role in day-to-day life, dedicated to both these scientists.
Now it's a decade of white graph,
Yeah,
right? Throughout India, in the journals I'm checking, everywhere it's coming up.
Yeah.
Even as that a fresher from an engineering background, that too from biotechnology, can Sam beware, people are watching.
Yeah. Sure. Delivery is the main part of efficiency.
Sir, I'm putting all these costly chemicals which are as good as poison, red labeled.
So where there is a prey,
There is a predator. Wonderful. Hi, welcome to the Agri Podcast by Chetan Dabke. So it's been first episode of our series about agriculture. So in this episode, we have someone very wonderful, a young and energetic guy who is Mr. Sam Prince. Welcome to be there, and
Welcome.
it's a privilege to have you in the in our show. So. Guys, today's topic is all about entomopathogenic nematodes. It's an EPN. It's biopesticide.
Pesticide.
Am I right? It's a
Yeah.
biopesticide. So, in today's topic, we are going to discuss about what are EPNs, what is their role in agriculture, how it is impacting the agriculture future of India, its role in organic farming, and henceforth how it has been reaching farmers and cutting the costs. So all these things. So stay tuned to get the information about all these details. Yeah. So welcome once again, Mr.
Thank
Sam
you.
Prince. So I need your permission to call you by your first name.
Yeah,
Yeah.
sure.
So please. So let us start this podcast. So can you please explain about yourself? So what are you? What do you do? And how did you got into this EPN things?
Yeah, okay. So basically my undergraduate was in biotechnology. It was
Okay.
B.Tech biotechnology.
Okay.
After that, unlike similar to every Indian household, I was asked to pursue a government job.
Okay.
So just like every single parent would.
Yeah.
I pursued government job. I had got into competitive exams.
Okay.
So for the
I'm exceptional in that.
okay. So up to 2017-18, I was into competitive exams. I was giving many tests.
Okay.
I cleared few. I didn't clear few.
Okay.
And the ones that I cleared did not turn into a job. So I was waiting for a right time. Then COVID happened.
Okay.
Just like everyone, those 2 years went off. So by the end of 2021, I was thinking of going for a trip. So
Okay.
the trip happened such that I happened to visit places where farming was actually a major role in day-to-day life.
Mhm.
So it was a major income source for every single family.
Where did you went there?
From Tamil Nadu, I'm basically from Tamil Nadu.
Yeah.
So based off Coimbatore. So from Coimbatore, it is a agriculture belt. So till Tanjavur, I had gone from Tamil Nadu. Then Kerala border, and then from Kerala till Goa.
Western Ghats.
Yeah, through the Western Ghats. And after that, Assam, Odisha, and West Bengal.
Mhm.
So these were the places that I had to visit. And places where I had went, I had observed one thing. The thing that was, people who are into farming were lacking the technological connect with farming.
Yeah,
At the present day, there is high technological advancements in agriculture.
Okay.
But the gap between farmers and the technology has been growing only.
Okay.
But it should have been reduced.
Okay. So that triggered you.
Yeah, that triggered me. Why not we reduce that gap?
Okay.
I didn't know how to do it, but I was determined to do it. That is all.
So you finished your undergraduate in biotechnology from
Biotechnology.
Karunya University,
Yes,
if I'm not
exactly.
wrong. Okay. After that, all these things happened.
Happened, yes.
Okay. So in biotechnology, we're all aware of these EPNs and all those things.
No, biotechnology, just like every single engineering student,
Okay.
biotechnology was just a subject for me. I had to finish a degree. That is what
We are
was in my
all
mind. Yeah,
engineers.
like everyone. During the last year, I was asked to do a project,
Okay.
just like every engineering degree.
Okay.
So when I was searching for a project, I didn't find anything interesting inside the college. That is.
Okay.
So I wanted to pursue something external. So when I went to searching for external projects,
Okay.
I came across Sugarcane Breeding Institute, which is
SBI, Sugarcane Breeding Institute,
It's Pioneer Institute of Sugarcane Breeding. It was established around in the early 20th century, that is in the 1910s. The headquarters is in Coimbatore.
Coimbatore.
Yeah, so I had gone through their projects which they are currently doing. And one
In your final year project?
Yeah, in my final year.
Okay.
So there was a topic of cryotoxins for BT.
Okay.
So that is how I got
BT,
introduced.
Bacillus thuringiensis.
There is a thuringiensis,
Okay.
yeah. So I got into that. After that, my mentor there was Dr. Singaravelu.
Okay.
So he was a leading scientist there. He was a principal scientist in entomology department.
Okay.
And my work would contain, like, I had to go to the nematology department and to the entomology
So
department.
this SBI is under TNAU or it's a separate entity?
It is an entity of Indian Culture of Agriculture Research.
Okay. Indian Council of
Indian Council of Agriculture Research. It is not coming under TNAU. It comes directly under ICAR.
Under ICAR,
Yeah.
like any other institutes. We have
Exactly.
NBIR,
Any research
ICAR,
institute.
NBIR and NAPHM.
Yes, exactly.
Okay.
Same like that.
Okay.
So then I had been introduced to entomopathogenic nematodes. The curiosity was that they were doing the luminescence test.
Okay.
So the bacteria, they had a specific characteristics so that when they infect a body of a host, they would emit a light. So what they were doing was they were trying to photograph it during the night time. So they would streak the bacterial colony and they would photograph it at the night time.
Okay.
Because there should be at least 0 to 1 to 2% of light.
Okay.
So
actually, an engineering student.
Yes.
Like you were like interim at the end of your project. For a final year, you happened at SBI.
Yes.
Okay, and you were under Dr. Singaravelu, as you said.
Yes.
So what was your role in that interim?
In the
As an
project.
intern? In the project.
In the project, my role was that I should identify the cryotoxins.
Okay.
There were around 10 to 13 types of cryotoxins. So my identification was around to work with Cry 1, Cry 4 and Cry 8.
And so, as you said, what is cryotoxin?
It is a toxin which is inside it is a toxin which infects the pest.
Okay.
So we need to identify every single toxin. Based on that toxin, the toxicology level differs and the mortality of the pest happens earlier or later.
Okay. In that, how EPN came in?
Yeah, EPN, the nematology department and entomology department are correlated.
Okay.
So they do the research similarly. My work was also associated with the nematology. So few of our equipments were there in nematology department also.
Okay.
So I had to visit there regularly.
Okay.
So during visiting, I had found this bioluminescence. Any college does not give you that much liberty to work in a lab.
Okay, that's very good thing that you have brought up this on this forum, and you are like giving credit to the institute, as we are proud to have an ICAR institutes. Like they are like supporting all the graduates in this farm. So it was very good to know that you were introduced to EPNs at that time. So you are fascinated by those tiny worms. So now to the viewers, let us explain, or I want you to explain that what are EPNs.
Okay.
The basic understanding of what are EPNs.
Okay. So EPNs, entomopathogenic nematodes.
Okay.
They are soft-bodied microscopic organisms.
Okay.
So they enter into the body of the host pest through the natural openings, which are the mouth and anus.
Okay.
And the cuticle. They enter into them and they feed.
Cuticle are the small holes on the body, on the epidermis layer, right? They breathe in through cuticles.
Yes, exactly.
As we have two nostrils, pests have multiple
layers of cuticles.
And they are cuticle, if I'm not wrong.
Yeah.
Okay.
So they enter into the pest.
Okay.
And their main source of food is fat.
Okay.
So they enter into the gut. The entomopathogenic nematodes, they enter into the gut of the pest. There, they release their symbiotic bacteria. That bacteria disrupts the gut.
Okay.
So feeding is prohibited.
All feeding and digestion gets erupted.
Yeah. That toxin starts to consume the pest from within.
Okay.
So then these entomopathogenic nematodes, they consume the toxins.
Okay.
And they reproduce from inside the pest. So what happens is, if one entomopathogenic nematode enters into a pest and it is able to kill the pest, it will multiply into thousands.
So basically we're telling that the rearing happens within the gut.
Exactly.
Of a pest.
Yes.
Okay, which is so it is predated by.
Yeah, we call it as a host.
Exactly, host.
Yeah.
Okay. So from basically EPNs are the entomopathogenic nematodes. The name itself, as it suggests. So it is a pathogen to insects.
Insects. Yes.
So now we are most worried about two kinds of insects in agriculture. One are harmful and another one are beneficial. So how can EPN differentiate between plant parasitic like entomopathogen? So what do you call it? So the
beneficial
pathogens,
insects and the pests.
Exactly, that's what I meant. So how can EPNs, can't it affect beneficial pest, or it will affects beneficial insect? As widely known, does it affect them honeybees also?
So to understand that, we need to know the basics of EPN, how they function. So these go in search of prey. It is a predator-prey mechanism. So they go in search of prey. How do they identify the prey? They identify the prey with chemical signs that are emitted from the pest.
Like pheromones?
Yeah, exactly like pheromones and heat signatures and so on. There are multiple factors. So these chemical factors, these chemical inputs that are given by the pest, these EPN are able to identify it. So these chemical factors differ from the pest and from the beneficial insect. That is why EPN is host specific. So entomopathogenic nematodes target only the pest and not the beneficial insects or the beneficial organisms. For example, earthworms. There will be a concern there, because we've been receiving multiple questions on that. Do entomopathogenic nematodes affect earthworms? If so, why not? That is because of the chemical factors that has been inhibiting from the pest. So EPN identifies it and it classifies them as pest and not so dangerous pest. So that is how it differentiates it.
Wonderful. So there is a lot of research data available on this, as you claimed. So it doesn't affect the beneficial pests at all. So only the pests which cause issues to the plant are being killed. So normally there is a term, or there is a coin of like fear of nematodes. Normally because of melodagine species. The root gets like the root gall nematodes and all this. So what is the difference? Are they both of the same families or different families? How to differentiate as a normal farmer what are nematodes and what are entomopathogenic nematodes? What is the difference between two of them?
So for that, we need to know what are nematodes. So nematodes are basically soft-bodied organisms. They are of three types. So free living, entomopathogenic, and plant parasitic. So free living nematodes are the ones that we see which are responsible for decay of organic matter and human bodies. So they are called saprophytes. Exactly. They are saprophytes. So those are free living. They have an extensive classification for that. So saprophytes are one type. And then comes entomopathogenic nematodes. Then you have the plant parasitic nematodes that cause the root gall and then tomato and various species.
So those are under plant parasitic nematodes.
Plant parasitic nematodes. So these are the three differentiations. So in case of if I apply, there is a question that if I apply nematicide, will EPN also be disintegrated? It does not affect EPN because it emits a certain behavior, EPN. So it avoids itself from being in contact with nematicides.
Wonderful.
So it removes itself from that place of contact, and then it moves to another position. So this range of the pest, the range of the pesticide that is being applied will be to a limited portion. So entomopathogenic nematode will move away. There will be mortality, but not extreme levels. There will be around 2 to 5% or 5 to 10% mortality. Because we cannot accurately predict that there won't be any mortality. There will be, but not significant amount.
So now we have understood about EPN on a basic level. And you and your story that you happened at SBI and you got all the exposed to this EPN. So that is wonderful thing. Now correlating things. Now I am interested in knowing that. So you know about these things, and to the viewers, I want to I feel extremely privileged to share this dais with a guy who is a licensee of ICAR on this novel entomopathogenic nematodes. So he has his own company, Creator Agro, if I'm not wrong. So Creator Agro happened 2.5 years back, if I'm not wrong. So we're a licensee of our own ICAR. So that is a very good thing. So now can you please explain about, as we know what are nematodes now, so what is the history of nematode? Why it has not been studied, like why we are not being introduced it a decade back? Because all these 1 decade, now even today in the Karnataka newspapers, we have got that our organic carbon is coming down. So similarly, it is the situation of Tamil Nadu and most of the Deccan Plateau. We are losing our soil's fertility. So I think the extensive usage of weedicides, less manual labor in the last decade is a trigger point for them. So similarly, and there is an extensive usage of pesticides.
Yeah.
So why didn't the government or the ICAR didn't introduce to us EPNs maybe 10 years back or a couple of decades back? So what is the reason? So what is the history of nematodes, Sam?
Yeah. So
especially EPNs.
EPN, okay. So EPNs were first identified or classified, you can mention it, during the early 20th century. That is during 1930s, we can assume.
Okay.
So Dr. Steiner, he was the first person to identify it. So that is a peculiar story. Like during those days in the early 20th century, every American household had a yard in front. A front yard or a backyard.
Lawn.
Lawn. Exactly, lawn. Okay. So one day he happened to observe that his lawn had patches. And the next day they were increasing.
There was
brown spots.
Vegetative growth.
Yeah.
Okay.
No, there was no growth there.
Okay.
So there was a bald spot there. So he happened to notice it for the next almost 1 to 2 weeks.
Okay.
Then as he was a nematologist earlier, so he was thinking that maybe it may be due to pest, but every pest will have another predator for it.
Okay.
So why not that be associated with nematology? Why not it be a nematode?
Okay.
So he started
that thought.
Yeah. So he started isolating those soil samples, and he started isolating the region where the bald spots were. He happened to discover a pest which was attacked by any source we can claim as a pathogen.
So there was a pest which was getting
damaged. Yeah, it was almost damaged and it was disintegrating stage.
Okay.
So he happened to observe that. He, along with his mentor.
Okay.
So they both started to identify that and check whether it is a pathogenic species.
Okay.
So then they had identified that it was an entomopathogenic nematode. That is, it grows inside, exactly as you said. It grows and lives inside the body of the pest.
Host.
It feeds on the pest.
Okay.
So it termed to be a parasitic problem. That is pathogenic problem.
You call it as cadaver. Right?
Cadaver, yeah.
Cadaver. Okay.
That cadaver is the dead organism. That is a pest.
Which has been infested.
Infested, yeah.
Okay.
It was infested by a predator.
Okay.
That predator was later identified to be a entomopathogenic nematode.
Okay.
So after that,
all this happened when
1930s.
Okay.
In America.
Okay.
So after that, during the 1950s, Dr. Weiner, Jaroslav Weiner. So he was the first person to commercialize it.
Okay.
So he started work on these entomopathogenic nematodes.
Okay.
He found that they were effective against different pests.
Okay.
So he started to devise a list of pests that were being affected.
Okay.
So during that time, there was a problem in America, mainly due to June beetles, as you call it as Japanese beetle or May-June beetles. They call it there. They occur during the May and June time after the summer showers.
This is all happening in 1950s.
Yeah, during 1950s.
Okay.
So at that time, there were almost 3 to 4, even 5 species of nematodes that were isolated.
By Dr. Steiner.
By Dr. Steiner.
Okay.
And
now
then
we are talking about Dr. Wieser.
Yeah. Okay. So he happened to test those species on those May-June beetles larvae. So only the larval form of the pest gets affected by entomopathogenic nematode.
So what has been discovered by Dr. Steiner is being used by Dr. Weiner.
Yeah.
Okay.
So at that time he had significant improvements, but the end result was not so, like you can say, satisfying for him.
Okay.
He was not able to attain an end result that would make that organism a breakout organism, so that it can be used in agriculture also. So he had stopped his research during that time, 1950s, and those cultures which were maintained during those time, they got lost to time.
Okay.
So after 1950, there was only few cultures that were remaining. So in 1965, he had devised extensive manual, so that you can classify a different pest and classify different types of nematode based on their morphology and their feeding habits, and how they develop in a specific situation. So at roughly around 1965-1966, he isolated. In 1950, there was few isolates that were left. Only the major portions were lost to time, but there were few left. 1950, he isolated an organism which was named, if I'm not wrong, D136 or D166.
It is an EPN.
Yeah, it is an EPN.
By Dr. Weiner.
Weiner, yeah.
Okay.
Then in 1965, he isolated a sample from Czechoslovakia.
Okay, Czechoslovakia.
Yeah. So that, you know the distance between Czechoslovakia and America.
Yes.
Though both are different continents.
Okay.
So obviously they should not have a same species of nematodes.
Mm-hmm.
But what happened was both these species, which are isolated 15 years apart and in two different continents, happen to be the same.
Okay.
So that proves the point that entomopathogenic nematodes have been in the soil from time immemorial.
Okay.
So when soil was created on the surface of the earth, along with them, entomopathogenic nematodes were created.
Okay. Now, fast forwarding the time, this was the story of two scientists and this happened.
Yeah.
So, who commercialized it? Why didn't our Indian government work on that part on those periods? So, how did it came out? How did it started in India?
Yeah. In India, there was a species of entomopathogenic nematode isolated, which was termed as Heterorhabdis indica. Heterorhabdis indica. So, our government...
So, indica is related to India?
Yeah.
Okay.
Similarly, almost roughly you can say.
Okay.
So, then they had isolated it and preserved it because they didn't have the technology at that time. Indian government. It was isolated by ICAR, basically. During that time, ICAR was not a substantial institution as it is today.
Okay.
So its roots were, not so wide.
Mm-hmm.
Now ICAR has a footprint in almost every single district in all of the states of India.
Okay.
And there are subsidiary organizations to ICAR for every specific crop, like Sugarcane Breeding Institute, for coconut research, and for groundnut research also. Yes. So, due to the lack of availability of technology, it was not pursued it further.
Okay.
Then, during the late 20th century, people were testing about the host specificity. That is, do these nematodes affect a wide range of pests? Okay. So, if they do not, then there is no use. Like you will be having 1,000 varieties of nematode, and you will be having 1,000 different types of pests. Each species will be affecting only one. That would not be feasible.
For any kind of
any commercial production also will not be feasible.
Yes.
Yeah. So after that, the host specificity tests were conducted. So that is why it took us almost 20 to 25 years, and then NBAR was the first institute to commercialize.
National Bureau of Agriculture Insect Research, Bangalore.
Yeah, Bangalore.
Okay.
So they were the first to commercialize this.
Okay.
But they are isolate.
I'm sorry.
Yeah.
Which variety did they commercialize? Which species?
Heterorhabdis indica. That was the first commercialized.
Okay. Yeah. So it is the virulent one.
Yeah, it is a virulent.
ICAR is working on that part. So if I'm not wrong, that has been tried and tested in all different soils of India.
Yes. Extensively
the story I can relate with Czechoslovakia and America.
Yeah.
Similarly, in India, from north to south, they might have worked on that.
Yeah, sure.
They have worked on it.
They have worked on it.
Okay. And they found that Heterorhabdis indica is the more virulent one.
Virulent species, yeah. Okay. It was identified in India, in our tropical region.
Okay. So it is a Desi version.
Yeah, it's a Desi version of it.
Okay.
So
EPN.
After 2017, they had commercialized it using their own novel formula. Okay. Then in 2021, ICAR SBI, Sugarcane Breeding Institute, which was the first one to isolate Heterorhabdis indica. And
why sugarcane? Why Sugarcane Breeding Institute got into that? Yeah. That would be a fascinating thing to, pass on to our viewers.
Yeah. So sugarcane has a major pest, which is a white grub.
Yes.
You will be knowing that.
Yeah, the white
grub. And C-shaped and
kind of root eater.
Yeah, root eater. It damages the pest at a stage where after the summer showers have come.
Initial showers.
That is during the March, April, May time. Then it starts its mating, lays eggs inside the farms, and then it starts its life cycle. Life cycles consist of 3 instars.
Okay.
There are different types of white grubs, almost 2,300 identified, and 23,000 non-classified.
Okay.
So it is a wide, extensive pest. It not only is feeding on sugarcane, it feeds on many other crops. But since it's in a Sugarcane Breeding Institute, they concentrated on sugarcane.
White grub.
Yeah, one crop and its major pest.
So white grub, they have this isolation has been made infested on white grub.
Yeah.
By Sugarcane Breeding Institute. Specifically on Heterorhabdis indica.
Yeah.
Okay. And what happened?
So they isolated. This was a later isolate. The earlier isolate was also preserved, but this was a later isolate. The later isolate and the earlier isolate, the differentiation between them is the earlier isolate was from a soil.
Okay.
directly from a soil. But
Okay.
the isolate from SBI, that is sugarcane breeding, that was isolated from a cadaver of a pest. We can recall that Dr. Vena,
Yes, Dr. Weiner, what
he
he has
had
done. From
observed that,
Czechoslovakia.
yeah. So similarly, this was also identified from a pest from a region called as Anakatti, which is around 30 to 40 kilometers inside the district of Coimbatore.
So a stainer found on a disintegrated pest on a stage.
Yeah.
Similarly, SBI was able to trace out one
They had multiple cadavers also. Yeah.
on one particular cadaver. They have isolated and which has to be which was found out to be accidentally
Heterorhabdis
indica.
Yeah.
Okay.
So their technology is based on a powder formulation.
Okay.
So the differentiation between NBR and sugarcane breeding institute is the formulation is different.
Okay.
So this powder formulation, what happened was the shelf life of this powder formulation was proven to be around 9 months to 12 months.
12 months.
Yeah, with a liability rate of almost 90 to 95%.
So mortality rate of 5%.
5% to 10% was there.
Okay.
So
by SBI.
By SBI, yeah.
Okay.
So this was a game changer. Like a farmer can buy a product and he can keep it for the next season, then apply it. A dealer can buy the product, store it in any condition.
That happens in many cases.
Yeah, because entomopathogenic nematodes are very specific to temperature and moisture.
Okay.
So they need moisture and they need temperature.
Okay.
Temperature range would be like a room temperature range of 27 degrees to 30 to 32 degrees.
Okay.
So not every single dealer would have access to facility to keep it under the 28 degrees, 30 degrees.
Okay.
And that will bring down the shelf life also.
Okay. So going on this topic now, we have understood the history of nematodes and how did it came in India, how isolation has been done by SBI and how it has been commercialized by NBIR and after say 2021 SBI started commercializing it.
Yeah.
Okay. So you happen to be one of the first license taker.
Yeah, first few licensees, yes.
Okay, very good. I'm very glad on that. So tell me your journey now. So after licensing, how did it all went? How did it started?
Yeah, so after licensing, my initial spark was to bridge the gap between technology and farmers.
Okay.
So for doing that, I had a product now. I have a product now, which is an bio input.
Okay. So now, under Creator Agro.
Yeah, under Creator Agro.
Okay. So what is the brand name?
It is an Econema. It is branded as Econema. Yeah.
Okay. So it is only Heterorhabdis indica.
Both we have Heterorhabdis indica and the other licensed species, which is Sternenema glacieri.
So we never discussed about Sternenema glacieri.
Yeah. Okay. Sternenema glacieri was isolated from Steiner. That is why of the name Steiner, and then it was
Sternenema.
Steiner, and then the glacieri, Dr. Glacieri, happened to work on it during the later half of the 20th century. That is during 1970s.
Now, if Heterorhabdis indica is the virulent one in India, Sternenema is not from India.
Yeah.
It is from the outside. So why we are using both these species then?
You can recall that the Czechoslovakian species and the American species were both same.
Yes.
They had host specificity in both the continents.
Okay.
Similarly, Sternenema glacieri also has host specificity in India and abroad in many countries, and it has a temperature range that it can survive in a temperature which can exceed up to 35 to 40 degrees also. So that is why both these species were licensed for all licensees available. SBI had licensed both these species.
So which is more virulent? As a farmer, which one should I use? I should go for Heterorhabdis indica or Sternenema glacieri?
Yeah, so for a farmer, you need to know the pest.
Okay, so let us talk about in Bidar, the most dominant crop here is sugarcane.
Yeah.
So we have white grub infestation wherever there is low, like wherever the soils are much, hold moistures. So in that case, Sam, can you please explain, like if I have a root grub issue, which one should I use? Should I use Heterorhabdis indica or Sternenema glacieri?
Yeah. In soil application, usage of both is recommended. That is, both the species is recommended.
Okay.
Every single crop has a different dosage.
Okay.
So entomopathogenic nematodes, in the formulation, there is a specific count for it.
Okay.
As per the license, they have mentioned that every single licensee should maintain a count that is of 10 crores per acre.
Okay.
of Heterorhabdis indica, as in case of
No,
Sternenema
just we can come to this technical aspect about how
okay.
it goes. So I, as a farmer, want to understand which one should I use.
Yeah. So every single crop we can split it into 3 or 4 dosages.
Of which one?
Every application of both the species,
Okay.
both combined. So during the first and second application, we would recommend Heterorhabdis indica.
Okay.
So to know why, that is when the count comes in.
Okay.
So Heterorhabdis indica, once it is infected by a Galleria, that is a process of isolation of Entomopathogenic
We'll talk on
nematode.
that.
Yeah. So that will have a higher count.
Heterorhabdis
indica has a higher count.
Okay.
That does not mean that it is less virulent or more virulent, but it just has a higher count because it is able to reproduce more inside the host.
Okay.
So that when we apply it in the soil, that will make the possibility of contact to a pest more.
Okay.
So during the second or the third and fourth application, we go for Sternenema glacieri. That is because once the contact has been made possible here due to Heterorhabdis indica, then Sternenema glacieri comes and plays a role wherein the application is close to the root zone. So whenever a pest passes through the root zone, it latches on to the pest.
Okay.
And then it enters the body through the natural openings as we discussed. So, and that is why we refer that both the species should be used in a dosage of 3 to 4 dosages.
Okay. So here still my answer is, we have used Heterorhabdis indica, which might have infested all the existing whatever the pest it is, or the white grub.
Yeah.
Then after some days, after multiple application, it is being a crop which runs throughout the year. It's a 12-month harvest crop, probably 10 to 12 months harvest crop. So in first couple of months I went for Heterorhabdis indica, and if I see total control, there is no visible symptoms, then is it advised to go for Sternenema, or I can stop there? Because here I have understood that these tiny worms can replicate inside my soil, and if I have a good organic carbon, they are going to sustain there for long. So what happened in that case? So should I use both, or should I settle for one if I don't see any visible symptoms?
Yeah, the pest emergence is based on rain patterns. So during the first emergence, that is before we use the first dosage, that time the pest emerges, and then it is being controlled by Heterorhabdis indica. Then there might be a shower, or the leftover pest that is not being affected due to Heterorhabdis indica, due to various factors, which may be contact might not been happening. It might have been feeding in a different area apart from the area that we've applied it. So that also is a possibility. So those pests will survive. They'll advance to the next level. That is the next instar, the life cycle. So these pests, in case of sugarcane, it is a 3 instar pest. So during the first instar, it does not feed on the roots. And Heterorhabdis indica, when we apply it in the first application, it targets the first instars. So those which are missed by the first application, they turn into the second instar. So in this second instar, this is where the feeding happens on the root zone. So once the feeding happens, it will continue rapidly. So almost a host of 100 to 200 pests can completely erode a single field overnight. There is a possibility of it. So once some farmer sees that it is being controlled, the first initial stage is being controlled, he won't be able to find the second stage because it will bury itself deep inside the soil. The top layer is where the farmers can isolate it. They can be able to see it. Not every farmer will dig every single ratoon and they'll check it. So what will happen is there is a probability they'll miss the live pest. So then it advances to the second instar. That is where Sternenema glacieri comes in.
So Sternenema glacieri can go deep?
Yeah, it can go deep, and we are applying it to the root zone. That is where the feeding happens during the second instar. The first instar, it can be dispersed among the fields. So
first you are giving most population, the populated one, Heterorhabdis indica, where all the whitewashing will be done, and the leftover which might have traveled inside. So even that we are not leaving. We are giving Sternenema so that it goes inside. So can we mix both and apply at single time then? That would mean that the dominant species will come out. That will be more effective. So that would not be economically viable. Got it. So talking on the economical viability, as you explained, So it has been year we have been associated, right?
Yeah.
If I'm not wrong, in the month of August or September.
Last
So
year.
what I did was, there was a heavy infestation of wireworm in Bidar. Okay. So in some certain areas we have, like we are growing ginger, and the soils which were heavy, which are kind of black soils or basalt we call it, right? In those areas where ginger is being grown, at that area I got a call from farmer that there is a root rot. So then when I went to the farm as usually, and I have checked, uprooted it, I didn't find that there, along with the rot, there was some primary infestation. There was a hole or some kind of the roots got, the rhizome got infested. It was like chewing and all. It was a clear symptom. So at that time, through Dr. Harish from GKVK, got to know that there are EPNs. And I have to bring the name of Dr. Sunanda ma'am. She is from NIPHM, National Institute of Plant Health Management, Rajendra Nagar, Hyderabad. She has trained about EPNs for us like 4 years back, pre-COVID. I went to a training there, and we were talking about EPN. So we only knew about this plant parasitic nematode. At the end note, she was explaining that it is 2018. At that time, she emphasized that we are working on entomopathogenic nematodes. Maybe this lead to the future. Like NPV was there, right? In the West Godavari, they were using NPV and all. So she said that we are working on EPN. So that was the part. And then I dropped a couple of mails to ICAR to understand. So all this story happened, and suddenly when Harish sir brought that point, that when Dr. Harish sir brought that point of, Chetan, why don't you use EPNs? Then suddenly, because I was very worried about on this wireworms, normally farmers used bleaching powders, pyrethroids and all organophosphates, but there was no results because I can see that its cuticle is too thick.
Yeah.
And when that happened, I got to NBIR first. When I Googled, I got NBIR Dr. Jagdish sir contact, and I was in search with him, and he referred to his incubatee. They were sending samples. All these were happening in the pipeline. But as I studied, I had education in Tamil Nadu. I had always an inclination towards TNAU. So I thought, should I contact SBI? So when I contacted SBI, then if I'm not wrong, I got connected to Dr. Shankar Narayan. Yeah. So sir has guided you to me, right?
Yeah.
So throw some light on sir's work. How Shankar Narayan sir is working with EPN, and what is his journey so far?
Yeah. So Dr. Shankar Narayanan is one of my.
So you were his student, right?
Yeah, I was a student.
Glad.
My undergraduate project was under entomology department, and I happened to be working at.
So this your biotechnology final
during
year
those
story,
years,
intern. Yeah, as an intern.
Yeah, as an intern. So he was also one of my mentors. Thought that if you have a passion towards anything, you should work hard for it.
Wonderful.
That passion came from both of these.
Okay.
Dr. Singaravel sir and Dr. Shankar Narayanan sir.
Okay.
So then, if you come to the history of Dr. Shankar Narayanan sir, he graduated from Madurai University and did his PhD there in nematology, and he was extensively working in sugarcane, white grubs. So
in SBI.
Yeah, in SBI. Okay. Previously, he was working in NBIR also. There were few institutes that he's worked in ICAR itself. So after he came to SBI, he had concentrated more on deriving an entomopathogenic nematode species. So during his time, previously there was an isolate, and it was perfected during his time. So the era of white grubs, that chapter will always have a name, two names.
Can I interrupt you?
Yeah.
You said you used the word perfected.
Yeah.
These are naturally present in soil. You have just isolated it, gave it a prey, gave it a food, then we have replicated it. So where does the part come of standardization of this thing?
Host specificity. That is a term we use to connect with perfection. So a pest, entomopathogenic nematode species which can infect a wide range of pests is known as a close to or near to perfect species.
So identifying that particular host where the like we call it as breeding or rearing is more.
Yeah.
Okay.
So that was perfected. That was isolated or
for white grub.
Yeah, for white grub. White grub is the major
menace in
almost every single district in India.
Yeah.
So that is how it was done, and sir was one of the pioneers in that stage.
Wonderful.
The white grub era, as I was mentioning, will have a page specifically dedicated to both these scientists.
Now it's a decade of white grub,
Yeah,
right? Throughout India, in the journals I'm checking, everywhere it's coming up.
Yeah.
Even yesterday in one of the WhatsApp group where we call it as one of the good horticulture solution group, we were just talking with scientists. They were talking and like, why can't India have a plate full of white grubs?
White
At
grubs.
least the disease will come down. Like Japanese people or Singaporeans eat these pests. So it's just a fun talk.
Yeah.
So this era is completely of white grub. Okay.
So after isolation, they had perfected it and then commercialized it, and that is how I got to know about it and the commercialization. Sir had contacted me I had contacted sir actually first. I had asked him for advices on what to do to bridge the gap. So sir was saying that there was a commercialization of our product itself. You are more associated with it. Why not try it? So why not try it? You have knowledge about it. I can help you with it. I can impart knowledge for you, but you have to do the field work and the other works related to the success of the product. So he gave me the initial push to try and venture into the field.
Wonderful. So you set an example that a fresher from an engineering background, that too from biotechnology, can be an incubatee of some of the novel technologies by ICAR institutes, and you became an entrepreneur where you are selling solutions right now. Am I right?
Yeah.
Wonderful. Okay, so taking to the next part now. So we have understood all these EPN stories, histories, how did it getting you. Now I want to understand that there are n number of pesticides available to deal with the root-borne pest and soil-borne pest. Soil-borne pest. So why didn't the companies like I don't want to name any brands, why they are not being commercially buying EPNs and manufacturing them? Why they are not doing?
So entomopathogenic nematode production process is a precision-based process. So even though companies have a bigger purse, that is, they have the financial capability to perform it, they assume that the infectivity rate or the success rate is considerably lower. That is, success rate of entomopathogenic nematodes or other biocontrols is successively lower compared to chemicals or chemical inputs.
So here I have to put another point. I was discussing with one of our entomologists from our College of Horticulture, and while having the discussion, he explained at the lab level EPNs are doing good, but you are the guy who is working on the field on day-to-day basis. As today we were on the fields, we were finding the pests and all those things. Similarly, their data says that, or their experience, whatever they shared, is that only the efficacy of EPNs on the field level is 40%. So how you are facing that? So literally you are selling a solution from an ICAR. So why if it is 40%, why ICAR is being commercializing it? So what is the flaw here? Because people who should guide us are also saying that it has only 40% efficacy. But as you said, the answer is satisfiable. The chemical companies are behind. I'll come to that part again. We'll talk about this chemical wala first. Then let us go to the efficacy part. So as you said that they think that the chemical efficacy is more, so they are not breeding EPNs. But at the same level, from my entrepreneurial journey where I started, I want to be an exporter. So when we went for exports, the biggest level we are facing in our agricultural produce is minimum residue level, the toxicity level which is remaining in the foods even after harvesting for so long. So by using EPN, there is not going to be any toxic or residue in our food produce. So I'm not getting the point. If the chemical efficacy is more, even they are having impact on human health or whoever is eating it. It is affecting the entire ecosystem. So how do you deal with both these answers? Because one scientist group claims that it has only 30 to 40% efficacy, and here you can see that the guy with a big purse don't think there is an viability. But you are an entrepreneur emerging out of both the streams. you are claiming that its efficacy is more than 90%. You are claiming that economically it is viable to the farmer. So can you answer this?
Yeah, so we'll split that into the same two questions that you asked.
Okay.
First, we'll come to why do chemical companies not opt for it. So farmers basically require results.
Yes.
In a shorter span of time.
Yes, obviously.
So chemicals give you those results in a shorter span of time. But the after effects, even though they have to be mentioned to the farmers,
Okay.
with all due respect, many farmers do not take that into consideration
Okay.
while they are applying their chemical control.
Obviously, because we are illiterate in that part, right? As a farmer, as being a farmer, we are being illiterate about the hazardous effects of chemicals.
Yeah. So what happens is, when it gives you a result, you'll be satisfied with that. So why would you go for another option?
But now as an FPO, it's my role to bring the toxic levels in our foods, right? The residue levels.
So people like you who have an interest and a social responsibility,
yes,
you all bring out the actual menace that is being caused by chemical inputs.
Okay.
So in due course of time,
I don't like getting praised this time.
no, I should give credits to you because for your efforts.
It all goes to Department of Horticulture. Yeah.
And also for your work also. I should give that because not every FPO is into so much of extensive work also.
We'll do that. We'll do that. We are learning from each other. Yeah.
So when this happens, there becomes a social shift. So people start to gain knowledge about the menace that is being caused by chemicals. So ultimately what will happen?
We want an alternate solution.
Yeah.
Exactly.
So that is where biocontrols comes in.
Plays a major role.
So now I think that would have answered your first question.
Yeah, I can understand.
Because of this factor, chemical companies do not.
Can I see this in another perspective, that over a period of year, chemical companies might get forced to produce EPNs if our government take this into consideration. Hope the policy makers watches this video.
Yeah.
Okay. So please go ahead.
So eventually it will be forced upon the chemical companies that they should adapt to entomopathogenic nematodes
or any biological solutions.
Yeah, it will happen, but the time frame is what we are waiting for. But we will be a little ahead of them. That is all.
Wonderful.
And coming to your second question, there is a statement that it is only field efficient of 30 to 40%.
Yes.
So efficiency has correlation with delivery.
Sam, beware, people are watching.
Yeah. Sure. Delivery is the main part of efficiency. That is how we consider efficiency.
Okay.
Once you deliver it in the proper way and the proper method and the proper time, you get efficiency at a desired range.
Okay.
So instead of people had concentrated on the efficiency only based on laboratory conditions, and when they come to the field, they have a general application method, not crop specific or pest specific. So
which you claim that you have worked.
Yeah, so that is where we differ from everyone.
Okay.
So we extensively work on every single crop. Every single crop may have 2 to 3 major economical loss pests. So we differentiate the application methods for each pest in each crop, and the time of application also we take into consideration. The earlier the application, that is during the earlier stages or the earlier instars of the pest, will give you a higher chances of efficiency. So we claim that we have almost 70 to 80% result.
You claim 70 to 80%?
70 to 80% result, provided the time of application and the method of application is strictly followed as we recommend.
Okay. Now coming to the point, as a farmer, I can't, be sophisticated if it has to be. So what are all those factors which a farmer has to follow? Because if you set a procedure that you have to do this, do that, farmer can't do that. It has to be, there should be a feasibility on usage of product. Then we can claim it. See, you might have novel technologies, good product, and it might restore the ecological balance which we should have. All those things are fine. But if a farmer, can he handle EPN easily, or what are all the parameters you say that before using EPN, these should be SOPs of using it, standard operating procedure? Can you please just throw a limelight on that part easily?
Yeah, sure. So EPN
I hope it is not a business secret.
No. EPN, the handling of EPN does not have any specific requirements.
Okay.
But the application,
so it comes in a talcum powder?
Yeah, it comes in a talcum powder. So there is no harm in handling it. There does not need to be any specific protection equipment will be used for applying it. But the application is where it differs. So while they are applying, there are two types of method, like irrigation is of two different types, flood irrigation and drip irrigation.
Yes.
So for every single type of irrigation, there is a different type of application. So for drip irrigation, there is a specific pressure in which the drip system has to be maintained so that there is uniform dispersal.
Okay, there are so many farmers who are not maintaining it. I have seen in the field level, even it has been clearly mentioned on the what we call mainline and subline that maintain 2 kg per centimeter cube. No one is maintaining it. So that is the reason their drip and all are getting clogged. So here you said that we have to maintain a pressure. Can you be a little bit precise on that part?
Yeah, okay. So the pressure is related to the survivability of EPN. So EPN can survive in 1 to 1.5 bar pressure in those ranges. So maintaining that, we have been associated with FPOs all around India. So FPOs, they are directly connected, like yourselves are directly connected to the farmers. So our sharing of knowledge comes through FPOs to the farmers. So FPOs can directly advise the farmers to maintain those levels. So
what happens if I maintain 2 kg per centimeter cube pressure, and if I fertigate EPNs through my venturi, what happens?
There will be a 30% loss or mortality of EPN, because due to the pressure, the body of the EPN gets disrupted.
So you mean the cell gets damaged?
Yeah, the total body gets disrupted. Yeah. So there will be a 30 to 40%.
So you say that all these worms, get...
Yeah, they'll be split up. Yeah,
split up. Oh, wow. Okay. So have you tested it, how it splits and all those things?
Different types of pressure we tested.
Pressures you have worked on it?
Yeah.
Okay.
Even through drone spraying, that is a coming up sensation of...
Are there research papers on this?
On disruption? Actually, there are not at present.
So why don't you take this?
Yeah, we are working on it.
Please. Because I believe in a scientific approach. So please go ahead.
Yeah, sure.
Yeah. If there is anything that if I can associate with you in the farm level, I would be happy to get associated, because we have 1,200 plus farmers who are working with us. Let us see how we can relate it. Yeah, please go ahead.
Your help would be of great
Sure. We would be happy to associate, Sam. So first parameter is kg.
Yeah.
Okay.
So that comes under drip irrigation.
Okay.
So for flood irrigation, there is a manual type of application. So the pest feeds on the root.
Okay.
So while application, we have to target where the pest can feed. The pest has a range of motion around the root. So we apply it directly to the root. That is near to the root, using a manual method, like say a crowbar. We make a small hole of 10 to 15 centimeters, and then we pour the solution.
So literally feed it.
Yeah, feed it directly to the
root
pest
zone.
Yeah, that is where the pest starts its feeding. So that method provides us more percentage of contact. The probability of contact is higher. Even through drip irrigation, the pressure factor is set so that we have a probability of higher contact.
So this was second parameter.
Yeah.
Okay. Is there anything else?
Yeah. So then coming to the third parameter, that is moisture level.
Okay.
So irrigation of the farm before and after application is a compulsory factor.
Okay.
Almost every single farm is being irrigated at a regular interval.
So being a microbial culture, it can sustain only if there is a sufficient moisture in the soil.
Exactly.
Okay.
So these three parameters would not mean that it is going out of the way for a farmer.
No, these are all okay.
Yeah.
These are all we can communicate with them and we can make them follow it.
Yeah. So
these are all enough?
These are the major specifications that has to be followed by a farmer.
Okay.
So the talk is that it is a specific organism, the specific conditions have to be maintained, there is a specific delivery method, and even if the delivery method misses, the efficiency comes down. So the generalized view is this, but if you go down to a micro level, these can be addressed easily. Every single issues can be addressed easily, and not so easily, but through the facilitation of FPOs,
guidance.
We can, through the guidance, we can address it. It is not addressable, non-addressable.
You are already addressing it.
Yeah,
right?
we are addressing it. When we have other helps from other institutions to address it also.
So coming to that part of Shankar Narayan sir.
Yeah.
So what happened? My wireworm story stopped there. So what I did was I just picked some wireworms. Even our Viru was with us. So we picked wireworm, we put it in a petri dish, and we have given some cultures as we got samples from SAM and other institutes. So I had T1, T2, T3, all three things. One is being treated by yours, another one is being treated by others, and another was controlled totally. So I got plenty of wireworms. So what happened was, when I used yours, so that was my trigger. So when I used yours, the infestation was so strong, and you were so good in explaining all the procedures. Hope you never used chat GPT for that. So just kidding. So what happened was, the disruption was too good. The wireworms got infested easily. So then it came inside me a belief that, okay, let me try in my farmer's field. So when I started circulating them, I got tremendous result. That was the final, because we use a lot of pyrethroids as advised, and package of practices it has been advised. But finally, when we started using EPNs, it was a miracle. Till the crop ended. See, what happens in ginger is, after February, the crops, mostly March, June, most of the time, January or February, the crop gets, dormant. And all the superficial, like we call superficial foliar growth gets dormant, and it gets dried up completely. So it becomes like a trash of ginger. So at that time, what happened is, the pest incidence will be more even at that time, because of warm climate and all. And mostly we will be irrigating. So wherever there is moisture, it attracts pest. So before using EPN, we have to use repetitive usage of chemicals during the harvest times. Okay. Even without knowing MRL levels, we have used it. But after using EPN, I can give you some credit for that. So what happened was, there was no need for repetitive application of chemicals. EPN gave us a good result, and during the month of June we are harvested, and July still ginger is being harvested, and there is no single pest damage I found. So wonderful for this innovation. So now coming to the next part, let us talk about pest specific things. So the major menace we face is, one part is on sucking pest, another one part is on chewing pest or lepidopteran pest or cutworms or all those things. So how you want to take it further from here? Like I gave you two issues. How like EPNs can come in and play a major role in controlling these two kind of pests.
So host specificity again. EPN have a host range, under which comes sucking pests and chewing pests also. So, but the delivery method, as I mentioned earlier, the delivery method plays a key role here. So the delivery method is that we mix formulation, and then we take out only the top layer of the concentrated solution, and we add a wetting agent. And now comes the time of delivery.
Wetting agent, so
wetting agent along with the solution of EPN.
While fertigating it?
No, on spraying.
So we never came to. So now you are talking about sucking pest or the foliar pest?
All the foliar pests,
All the foliar pests. Okay, so for foliar pest, we are mixing
the
wetting
EPN,
agent.
Along with wetting agent,
If I'm not wrong, it is to maintain moisture for the optimum level.
Exactly. So that the evaporation does not happen and the temperature does not raise.
So it is all silicon based wetting agents.
Non-ionic silicon based wetting agents, So once you apply it, the time of delivery is important. During the evening hours, that is after 4 o'clock, during the sunset hours,
Why?
The sunlight intensity would be less, and the wetting agent would not evaporate so easily.
So just to maintain moisture.
To maintain moisture. And the feeding of the pest will be during the evening hours to the early morning hours. So then we'll be able to create a higher possibility of contact with EPN and the pest.
So even these all plant parasitic things act in the early morning or evening?
Evening only, So that is.
So does even UV affects these worms?
The intensity of temperature, the two conditions which are essentials for survival, moisture and temperature. So temperature here plays a role. So when it dries up, there is no moisture, the temperature is high. So eventually EPN will disintegrate. So that is why we are adding a wetting agent, and the time of delivery being evening, we will have a contact time of around 12 to 14 hours. So then it will increase the possibility of contact. So repeated applications will be required for every single foliar pest. Around 5 to 7 applications for each crop. That is also crops.
That depends upon crop
life also.
If it is a 180-day crop,
the flowering stage would be the one that is in question. So every single crop has its time of delivery. So that differs from crop to crop.
So let us talk on crop specific. Okay, just to understand this topic in a very detailed manner. Say tomato, which is trending right now. People are buying fortunas by selling tomato. They are making their fortune. So understand in tomato the major pests like we face will be shoot borers in kind of lepidopteran pest if I'm talking. Fruit borer. Fruit borer is the major menace rather than shoot borer. I should correct myself here. So what happens is the Spodoptera lutura, if I'm not wrong, so it feeds on the fruit. So if I spray EPN if I see like there are some fruits which are getting affected, and if I go for EPN spray, how will it help us? So and coming to again, we have two types of species as you mentioned, Heterorhabdus indica and Sterinema glacieri. Which one should I use for foliar pest?
Okay, so in this case, we would prefer Sterinema glacieri due to its higher temperature resistance. Okay. So while application, we cannot say that the field would not cross 35 degrees. The temperature in the field would not cross 35 degrees.
Sterinema can tolerate
higher temperatures compared to Heterorhabdus indica. Yeah.
How much?
There is a range estimated around 40 to 42 degrees.
Have worked in Rajasthan then?
Yeah, it has worked in Rajasthan.
Wonderful.
It has worked in Rajasthan.
You have worked in Rajasthan?
Yeah, we have worked in Rajasthan.
Good.
In soybean also, we've been working on it.
So in which crop you have worked in Rajasthan?
Soybean, we've been working. Tomato, we've been working. Cauliflower, cabbage, we've been working.
Okay.
So we have been getting...
And there were results?
There have been results. Okay. I would mention the success rate only based on the results that I've been getting. Only if it crosses 80%, I'll be satisfied with that.
So you're warning me, beware.
Yeah, every single data that I'm mentioning will have...
I can't question you.
Not that. You can question, but it's my job to tell it. Yeah.
Okay,
so
wonderful.
That 80% is what we consider as an optimum level. Anything below that, we do not mention it to the farmers or the consumers also.
Okay. So coming to our crop. So tomato, you advise Sterinema glacieri.
Yeah. So the time of application again. The occurrence of the pest has to be noted. So when the occurrence
are all these leps are nocturnal?
Yeah, they are nocturnal.
Nocturnal in habit. Okay.
So the time of infestation has to be noted. That is when the life cycle starts, the duration of their life cycle, and their feeding time. These three are the important factors. So when we analyze that, we'll know that the larval form has a specific life cycle and a specific time. So that time is where the application has to be done. We have to note a specific point here that there can be overlapping generations. Like if the pest emerges today and the life cycle is for 15 days, during the 10th day there will be an overlapping generation coming along with it. So we recommend that once a week or once in 10 days to go for a spray. So we'll be able to cover the overlapping generations also in that, and until it matures to the adult or the pupating stage, we recommend it to be continued for that.
So eventually you are disrupting the reproductive cycle of a predator.
Exactly.
Sorry, pest. Yeah. Okay. Eventually bringing down its population.
Yeah.
Isn't it a time-taking process?
Yeah, it is a time-taking process.
That I have to be aware.
Yeah, because in case of chemical, if we know, it will totally disrupt the total life cycle. And
of all the beneficial and harmful
exactly. Pests. Here, we are able to sustain the beneficial organisms also.
Because sometimes when me and Veeresh work with farmers, we are very amazed we are astonished to see the kind of pesticides, nanoctinides, like organophosphates dealers are recommending during the flowering phase. So how it will, we all know that once the pollinators get affected, then we will not get yield. So at that time, this is a wonderful...
Yeah.
Okay. So as you claimed that I can go for a spray every 10-15 days, should I plan EPN in such a way, because I cannot, totally leave chemical. Always an integrated approach is the best way. So nearing harvest period, I can go for EPN, or during the pollination, peak pollination, though there is no cross pollination in tomato, I'm just bringing it as an example. So in tomato or any other crop, during say watermelon, it is highly influenced by pollinators. So at that time, can I take this spray then?
Yeah.
Because I have sucking pest issues now. I have thrips, I have aphids, I have whiteflies. So how Sterinema glacieri is good at controlling sucking pest now?
Yeah, okay. So while you are saying that, you will be applying
It's
chemical Steiner Nema
Steiner
Glycerin.
Nema.
Yeah,
Steiner Nema
Dr.
Glycerin.
Steiner.
Yeah, okay.
And his
Steiner.
name
Now
after,
I'll not forget.
Glycerin because
I was
Dr.
thinking it's
Glasser.
Sterinema Glycerin.
Okay.
Steiner Nema
Steiner
Glycerin.
Nema Glycerin.
Okay.
Dr. Steiner and Dr. Glasser.
Glycerin. Steiner Nema Glycerin.
Steiner Nema Glycerin.
Wonderful. Okay.
So now you are saying that you would want an environment where you will be using chemical inputs also along with EPN. Also.
Yes, with a gap.
Yeah. So that the gap, as you mentioned, that is where the role plays. The gap should be around 5 days. Once chemical input, yeah, that is enough. So that the residue level of the chemical is slowly disintegrated, and then when we apply EPN, that does not affect the efficacy of EPN also. So the 5 days gap is what we would recommend. Once you applied a chemical input, we would ask you to wait for 5 to 6 days and then go for spraying. And after spraying, again you should maintain the gap 5 to 6 days. That would be efficient, so that you will get a proper result. You will be able to visibly see the result. So that is what we recommend.
Okay. I'm being bombarded with, my brain is being like tempting me to bombard you with more questions, but I have to patience so that I can let you speak also. So it's wonderful thing. So now only 5 days gap you are letting, you are making me understand. So okay. So does chemical and even EPNs have compatibility? There are studies.
There are studies that few agrochemicals have compatible nature. At present, they are not in production in India.
Okay.
They have been banned. We would not want to use those names at present.
Okay.
So they have been tested. If the recommended levels of every chemical is followed by every farmer, there will be a certain compatibility level with EPN also, but not if it exceeds the recommended level.
Because why I'm coming to this point again, you even viewers might have a question that here we are talking about reducing the chemical, why this guy is bringing up mixing this with chemical. Because when I was working with, I was blessed to have spent my time with Dr. Ishwara Murthy sir, who was director of SBI. I had wonderful week with him in Pollachi area during the era of this Rugus whitefly. Yeah, I was with sir. So he said me that he was working on at that time it was called Verticillium lecani. Now it is Lecancinium lecani. At that time he mixed Profenophos tank mix with Verticillium. So I asked sir, why are you mixing a chemical with biocontrollers? And he said that I am using very sub-lethal dose. It is just 5 ml for 15 ml of water. If I'm not wrong, it's 5 ml for 50. So what Profenophos did is it just knocked down the pest it just knocked down and it became weak, and these fungi went inside it and were able to form colonies. So similarly, my point here was to if there is, like in case of wireworm where cuticle is so thick, and to increase the efficiency of nematodes, EPNs to be precise, can I mix some chemical so that it instantly knock down and block the what we call resistance of a pest, and EPNs can enter easily?
So the combination of these two have been studied, but there has not been any promising result for it.
Okay.
So
what is your suggestion?
I would suggest that an interval be provided for its usage.
Not mixing ahead.
Yeah, mixing would mean that there may be a possibility of mortality of EPN also.
There might be.
Yeah, there might be.
So there are still lot of researches
to be done. Yeah.
Okay.
So that is a topic which is still on the hung. So,
because it has to be done.
Yeah.
It has to be done.
So the efficiency is what a farmer or a consumer pays for.
During these kind of conversation, it pains me inside that why I didn't took Agri as my my study. I should have done that. It should have been my genre, because every day I'm seeing it in my real life. So wonderful, knowing all these points. So coming to the tomato, you advised me. So now let us talk about sucking pests. Yeah, please.
So for every pest we have a specific interval.
Same.
Yeah, every interval, and then during every interval, after the interval, they can go for chemical inputs also. So how these sucking pests are affected by EPN is as the same method for every single pest. They enter into the body, they disintegrate the body.
Of all the stages of sucking pest?
No, only the nymph stage.
Okay. When does the nymph stage comes? Egg,
nymph.
Okay.
Adult, pre-pupation, and then pupation.
Okay.
So after the egg laying, and then if it hatches out, The nymph in some pest, it has early nymph stage and matured nymph stage. So the nymph stage is where we target in case of sucking pests. And in case of chewing pest, the larval stage, obviously.
So over the period of time only we can see the results.
Yeah. The time is what is a major factor for few farmers.
Where do major insects pupate?
That is
Either in soil or stem or...
depends upon the insect also.
Say let us go for thrips.
It pupates on the leaf itself.
Leaf.
Yeah.
So does EPN affects the pupal stage?
No. The dosage would have to be at a higher concentration.
Mean you have to give more
Bombarding
population.
of the concentration.
Have you seen infested pupae?
We have seen, but not in thrips. There are a few pests. We have seen the pupation infestation. Like Spodoptera lithura species.
Okay. But it comes under sucking pests.
Sucking chewing pests. Yeah.
Okay.
In case of black thrips in chili.
Yeah, we were having that, right? Wonderful. Now I'll explain let me explain my experience. So we were growing 10 acres of bedgi chili, and I can still recollect that moment, and I was so happy because I'm a farmer who wanted to start, who started his career as an organic farmer, but over the period of time I was being forced to use chemical because there were no promising results, or I had a limited knowledge about organic farming. It was not that easy. We are eating the food which is not even being touched by pests. We are just literally eating those kind of food. So what happened is, what I wanted to ask you, like what I wanted to share is, so I still remember I calling you. So it was a huge infestation of black thrips. So, and you advised me, Sam, to go for Steinernema glacieri, and I took a spray, and within couple of days, if I have that footage, I'll share it in the video also. So after spraying, just within couple of days, because all these black thrips in chili were inside the flowers, and flowers of chili were like this. So literally there was no contact pesticide which was attacking black thrips, and there is no label claim of any pesticides company that black thrips can be hit. Isocycloserum was working well, that is Syngenta's isocycloserum, on trade name is Simodis. It was working well, but I can't use it for again and again. It might build resistance. So at that time, as you advised, I went for Steinernema glacieri, and it gave wonderful results. And within couple of days after spraying this, I saw flock of birds inside the field, and they were just feeding on that dead pest. So that confirmed that all these dead pests or maybe damaged pests were not of chemically killed. Chemically killed.
Naturally killed.
Yeah. So in chili, that was my wonderful experience. So yeah, it did work on black thrips. So your study on black thrips is it controls adults also.
Yeah, not the adults, that is the pre-adult stage.
Okay.
That is a nymph and the pre-adult stage.
Okay.
So thrips usually pupate on the leaf and in the soil. There is a research paper, there are multiple research papers that thrips pupate in the soil also. So while we are recommending for applications, we do recommend for foliar and precautionary method for soil also. So we will be able to increase the possibility of control.
So pupae, in case of that, sorry, I'm interrupting you again, but this is a fantastic topic, and I can't have you like this every now and then. Now I have to make most of you out.
Sure.
So if it is thrips are being pupated in soil, and if I'm giving Heterorhabdis indica and soil temperature is optimum is 36?
35 to 36.
35 to 36. So at that time Heterorhabdis indica will work. So if I fertigate my soil with Heterorhabdis indica and take a foliar spare of Steinernema, then will there be a sudden reduction?
No, there will not. Any biocontrol will not give you a sudden reduction in pest. It will first disrupt the life cycle, gradually decreasing the current generation from maturing into the next generation. And then when the next generation comes along, it will start disrupting the next generation. So eventually you will see that the adults, the reduction in adults formation, and gradually leading to total reduction of pest population. So that is how entomopathogenic nematode fungus functions in a setup of a field.
Okay. Now we are all talking about success of EPN. Now can you please explain where did it fail? On which sucking pest it failed, or which lepidopteran pest it failed, so that whatever my farmers invest should not go in vain, or I should not be a wrong advisory from them? Can you are you comfortable in talking about failures of EPN?
Yeah, EPN failure is because of delivery. So we'll leave delivery out. You are asking about specific pests.
No, I'm not talking about delivery or human errors.
Pest.
The specific pest where it did not work.
Yeah, okay. So then we come into the pest which is mealybug. So mealybug's morphology we have to know about it.
Okay.
The top layer of mealybug is a creamy layer. So
Maupuchi, right?
Yeah, Maupuchi in Tamil.
Yeah, in Tamil,
so
in papaya.
In papaya, in almost many crops it is there. So what happens is that creamy layer, it creates a shield so that entomopathogenic nematodes cannot penetrate into the body.
Okay.
So the total action of entomopathogenic nematode is prevented. So once that action is prevented, there is no infestation.
Okay.
So here there are some cases where it has affected, but that has been below 50 to 60%. So we consider that as a failure. Anything below 80%, as I said, is a failure to us. And in field level also, due to its peculiar morphology, entomopathogenic nematodes have not been able to successfully cause an infection in mealybugs. And coming to aphids also, there are varieties of aphids which aphids move faster.
Okay.
So that reduces the possibility of contact also. So entomopathogenic nematodes work on contact.
Okay.
So once they contact a pest, they are infested.
Okay.
So loss of contact results in loss of success.
Okay.
So these are few among the few pests.
So aphids and mealybugs.
Yeah, aphids and mealybugs.
Okay.
So among few, these are what we've been identifying.
Only two
we've been identifying.
Okay. So now then there is no need to make a note. I did not want to disrupt you in between.
Okay.
So in case of aphids, you say that what is the reason?
Their movement is fast.
Their movement is fast, so that EPN infestation doesn't happen. And in case of aphids or any sucking pest, there is a huge what I called the excretion of that honeydew secretion. Secretion, not excretion. Secretion of honeydew. So if there is a secretion of honeydew already being existed, especially in case of chili and all, so at that time can EPN work or wriggle through this honeydew?
Yeah, if the density of the honeydew is sufficient for it to wriggle along.
Because even it gives moisture.
Yeah, it gives moisture. So the structure, that is the basic molecular structure of that honeydew, if it is feasible for it, it can penetrate also. It can move along, not penetrate, move along.
It can move along the honeydew.
It can move along.
Okay, so the only reason is aphids are moving faster.
Yeah. The possibility of contact reduces.
So this is where the point comes. That is why I'm asking if we can mix chemicals along with this sublethal dose. We can restrict its movement and EPN penetrates inside. So that we can
weaken it and then
we can just knock it.
Yeah.
A temporary knockdown and we can use EPN. Please go for that study.
Yeah, so we will conduct a compatibility
we'll be glad. Now coming to the other pest, Lepidopteran pest. Say for example in okra we have huge issues.
Yeah.
In okra we have stem borer. Shoot borer, sorry, not stem borer. Shoot borer is a major issue. And the only label claim is about the use of CTPR, chloroantriniprole, that is only giving promising results. So the point is, if I spray EPN and there is already tunneling happened by that plant parasitic pest and it is already inside, can EPN travel inside the xylem and phloem of the plant flora and can it infest which has already been tunneled inside? So
for a general application, that would be impossible, like a normal spraying.
Okay. So
we may not know if the drop that we are spraying will enter into the xylem of.
So it is basically contact only.
Yeah, it is basically contact. So if they take special care, if the farmer or the consumer takes special care in investigating every single crop and every single tunneling, if they are able to inject it through an injection,
but that is not possible in case of okra and all. For orchards, I can do that.
Yeah. So that is where the time of application comes. Before the tunneling happens, once the eggs are laid, that would be our window to go for a spraying.
Okay.
So basically, as mentioned earlier, time of application, method of delivery, these are important factors for the success rate. So now, as you said, the success rate would differ if it did not work. when it's inside the tunnel. So
we should be aware of the application.
Yeah, that is why I said we should know about the pest, their life cycle, when the time of application, and at what stage we have to target it. So that is where it is a combined application method. So knowledge is where it makes a difference. So knowledge about every single pest makes a difference in its control.
Now about this traveling through xylem and phloem.
It can travel.
What, EPN?
That is known as a cryptic environment. There are three types of environment: soil environment, cryptic environment, and foliar environment.
Okay.
EPN functions almost equal to 100% in cryptic environment.
Okay.
Once it is injected directly.
Cryptic in the sense through the plant body.
It is an enclosed environment. Does not have any factors affecting it. Any external factors affecting it. So cryptic environment provides 100% result.
Wow.
But the application has to be precise. Which is
so if I understand this way, that if I give it in the root zone and it can enter through the, and if there is any borer up from the top, and if EPNs can sense it through chemicals or pheromone, whatever you claimed, so can through the root it enters into the shoot and affect the pest?
No, that is not possible for entomopathogenic nematodes.
But you said it can travel through xylem.
When we are applying from the
foliar
entry holes, the entry holes are the ones that are matter.
From root it cannot.
No, it cannot travel. Even though there may be a puncture in the root zone, it won't be able to travel. Only through the entry holes it will be able to travel.
So can I take that efficacy will be more if it goes aligned with gravity?
Yeah, that is what actually is the truth.
Logic.
Yeah.
Okay. Wonderful. This is outstanding knowledge. I don't think that YouTube has such kind of content yet.
Yeah.
Let us see. So now I have basic understanding about how to apply EPN, what are all the category, what are all the species being put to use and all those things. So chemical application, we have discussed a lot, actually a lot content. So now I want to, so the next question is like, while using EPN and what are all the various types of application on a preventive measures which should increase the efficacy before soil preparation? So how, because normally in biocontrollers we mix it with compost, let it multiply for a few days and use it. So how in case of EPN, if they, so say I'm using a compost where there are no predators, I should not call it predator, there are no pests to feed on. I mean, EPNs cannot predate it. So if I mix with compost, will they replicate or will they remain the same? So I mean, I'll put it precisely, without infestation of another pest, without the host, can EPN involve into reproduction?
They will enter into a dormant stage. Okay. That is like hibernation. So they'll curl up on themselves.
Samadhi.
They'll store their energy, then wait till the time the pest arrives.
Curling up, what is it?
Yeah, they'll curl up on itself. The head and the tail, they'll combine together. Not eat up, but it will touch together and it will curl up.
Do you have an image of that?
Yeah, we have it. We'll link that also.
Please share it. Sure. Please share it. I would be happy because the imagination is like you are giving a food for thought. EPN spiraling itself, eating its own tail. Wonderful.
No, there I would like to correct you. It won't eat its own tail.
Okay.
It will curl upon itself.
The appearance.
Yeah, the appearance. Okay. So what that will do, it will reduce its motion and its movement will be reduced. The energy needed for the movement will be reduced. So the fat stored inside the body of the EPN would be used less.
Who created EPN? Who created?
The same who created the whole soil and the whole world. Same EPN was created.
Wow. So
it has a peculiar motion for it.
Okay.
So that is how it stores it. So
what a beautiful answer you gave. You never claimed that there is someone whoever has done it.
Yeah.
Illan solla varla. Okay.
So coming to your question, that what would be the pre-planting measure? So before planting, before a week or so or 3 to 4 days before planting, we'll take up a basal dose. That is, we'll give it to the root zone. So entomopathogenic nematode at present have been included in IPMs also, integrated pest management also. So before planting, that basal dose will prevent any eggs which have been formed during the earlier seasons also. So these earlier season eggs will be carried over to the next crop. So then we'll be able to prevent even before the infestation starts. So in that case, once the infestation starts, we'll have to apply another dose. This dose will act as a preventive measure, and that will be acting as a systemic contact measure. So
Okay.
in both ways, it can be implemented.
Okay.
Including EPN and IPM would be highly efficient.
That is what I was meant.
Yeah.
Okay. Okay. So we can use it pre-planting
We can.
as a basal
But
dose.
provided the moisture level is maintained. Again, I'm coming to the moisture level. So if we
Can I
use
apply it and irrigate?
yeah, you can do that. Provided the soil is a little damp, not too dry. Like after you do plowing, the soil would be turned upon itself, and that will be totally dry for almost 3 to 4 weeks. We'll leave it as such. At that time, if you apply, EPN won't be able to survive because moisture is needed.
Won't be able to survive.
Won't be able to survive. Yeah.
There are chances it might survive
can,
also.
it can.
So this is all where the efficacy part comes in.
Yeah.
40 to 80%.
80%. Yeah.
Wonderful, man. Okay. So now coming to my questions I had while you explained. Can I mix it with? I don't know, but I'm still asking because you said that it has been tolerant to the chemicals. While applying basal fertilizers, can I put EPN also then?
You can, but as said earlier, a 5-day interval period would be recommended. You can. There will be mortality. So to prevent that, the 5-day interval period would be better.
So I cannot mix it.
Not that you cannot, but
if I'm putting DAP, can I add one packet of EPN to the DAP and just
broadcast it? No, broadcasting would reduce the uniformity of EPN.
Okay.
So like if you mix it with any mix like organic matter or fertilizer or cow manure, you mix it and there will be a clumps of EPN. In one clump, there will be higher population. And in the next one, it will reduce.
So fertigation is the best thing.
Yeah. Recommended is fertigation.
Fertigation. Okay. You said that the eggs gets infested.
Yeah.
But until now, we understood that only larval stage get affected. So can I claim that it has ovicidal properties then? I mean, can it kill the eggs?
There are certain pests which get affected. Like white grubs, where the eggshell is softer.
Okay.
In pests which are the eggshells are a harder material of a harder composition, that would mean that it will be a difficult penetration process.
Wonderful. So it was a wonderful discussion. So henceforward, we are heading towards the end of our conversation. So there are few questions I want to ask you. You can just answer that and we can come to the concluding notes. So there was another topic which I have promised our people that we'll be talking about role of EPNs in organic farming, which is a current boom. Our PM, Honorable PM, has a vision of creating organic India, and he is taking steps on that part. So how we can align or how we can utilize EPNs in organic farming? Yes. What is role?
So as I said earlier, entomopathogenic nematodes have been present in the soil from time immemorial.
Okay.
So they are a part of nature. So what is if we come to the concept of organic farming, it is usage of the nutrients available in the soil, which have fertilizing components and pesticidal properties in case of neem, for example. So that combined with a process of agriculture would lead to organic farming.
Yes.
Organic farming would result in preserving the natural setup, revitalizing it,
microbial flora,
preserving it and revitalizing it. So EPN, as it has occurred through nature, by nature, so it will act along with nature. It does not go against nature. It aligns with nature. So obviously it promotes organic farming. It is safe to the environment, safe to the application, safe to beneficial insects, as we mentioned, does not cause any harm to the applicator or any microbial properties of the soil or the beneficial insects. So ultimately it comes under the bubble of organic farming.
So just 2 words. Role is by revitalizing.
Revitalizing, yes. Exactly.
So we are giving back the soil, back to the soil, the organisms which we have killed by usage of so-called fertilizers and pesticides. Wonderful. Okay. The next question is, what is the perfect, what is the cost effectiveness? Cost effectiveness.
So
you can just explain your rates, how Creative Agro is dealing with it, all those things.
Yeah. So the rate has been fixed by Indian Council of Agriculture Research.
Okay.
So what they have fixed it should be affordable to any marginal farmer also.
Okay.
Not just farmer.
And entrepreneurs too.
And entrepreneurs too. Obviously, it has to be.
Yeah.
So that rate is around 550 range,
Okay.
exclusive of GST.
Okay.
So at that rate, any farmer can
At,
afford it.
which slab does it fall in GST?
It falls under the 18% slab.
I should write a letter to GST.
Yeah, it can come under 5%.
5%.
Yeah.
It has to, because it is an essential need.
Yeah.
Yeah.
So at that percentage, at that price range, it will be affordable to farmers. It can be affordable. I should not say will be. It can be affordable to farmers. And the usage and the dosage would be in a prompt way that either it will be 2 kilos, 3 kilos, 4 kilos, 5 kilos, only based on the infestation, pest and crop. They can differ. It can be 1 kilo or 2 kilos. That varies. So that the farmers will be able to...
What is the standard dose you are recommending?
So there is no standard dose.
Okay.
It differs from crop to crop and pest to pest.
Okay.
The dosage is based on how much quantity of EPN is required to infect and kill the highest range of pest infestation. That is highest in case of historical average.
So in case of I grow ginger, as we were discussing in the beginning, if I'm growing ginger, I want to go in a preventive manner and apply.
Yeah.
What is the recommended dose for ginger?
So preventive manner, as I said, pre-planting. We have to go for pre-planting.
Pre-planting, that to Heterorhabdis
Heterorhabdis indica would be best suited. So we would go for 1 to 2 kgs per acre. That would be one application. Then after planting, then once the stages of the larva start to appear, the occurrence starts to appear, we would go for 1 or 2 kgs again. And if that provides you almost a 60% control, and if there is no other significant damage while the crop is growing, we would stop there. If there is a late emergence in case of the larval form, then we would go for another 1 or 2 kgs.
I want to know, can you quickly explain about the life cycle of EPN in short? Yeah.
So it goes through 3 different stages.
Okay.
The adult stage, where it mates and it gives rise to the next stage. That is the infective juvenile stage.
Okay.
And then it does into the higher stages, that is the later stages of its life cycle. So the infective juvenile stage is what we use for the formulation and for the product.
So when you give your product, it will be all
Of the infective juveniles only. So that can survive in a field condition if there is optimum moisture for up to 2 years also. So if it is in a control environment, in a field also, it can survive to 2 years. So that would be provided the moisture level is there. So that would be an optimum life cycle to mention it.
Wonderful. And if I apply nematodes, EPNs, to the soil, and there are no prey for it, okay, and there are no preys, so what happens? Because I'm going in a preventive way, I'm not going in a curative procedure, I'm going in a preventive way. So what happens at that part?
It will become dormant.
For how long? If the moisture and everything is suitable in the dormancy phase, how long it can stay in soil?
More than 1.5 years to 2 years.
There are data, substantial data for that.
There are data.
Okay.
Even in field conditions,
it can stay there.
It can
in the
sustain,
soil.
yeah.
And whenever the
pest comes along,
and
it will get reactivated.
Pheromone signals, again it gets
reactivated.
Kill it.
Yeah.
Again the life cycle starts.
Continues, exactly.
The infective juveniles, adults, and all those things. Wonderful, wonderful. Okay. So can you just explain us, because once we use certain chemicals, we can claim that this yield we can get. So when recommended dose of fertilizers are being applied and all those things, what is the perspective in case of yield if I use EPN? So
EPN reduces the pest damage to below 30 to 20%.
Okay.
So when the pest damage is reduced to 20 to 30%, that inversely addresses to
proportional to the yield.
The yield will also increase. So a 60 to 70% yield increase can be expected, provided there is decrease in pest infestation below 20%.
Okay. So this lands me to ask you another question, that if I spray EPN with using silicon based wetter, and it will be there for around 2 to 3 days on the provided, say I go for Steinernema glacieri, so it will be there for 2 or 3 days, and the pest comes on the 5th day.
So then the pest comes on the 5th day. We recommend the reapplication on 7th to 10th day.
Every alternate week. So the pest...
For how long then? Until the flowering phase is completed, or until the pest life cycle is completed. Every single pest has a specific life cycle based on the climate conditions and the crop also. So in case of for example chili, we take it from the flowering phase until the 30th or the 40th day. So that will be around 6 to 7 applications.
Okay.
So as you asked, the 5th day pest, when it occurs, it will be controlled in the 10th day application. That is the second application. That's how it happens.
Wonderful, wonderful. Now as a farmer, let me ask you one question. It is like very basic minimum question which my farmer will ask. Sir, I'm putting all these costly chemicals which are as good as poison, red labeled, and I can see pests are moving there freely, mating, enjoying their lifestyle, eating my crops, spoiling my life. These mere nematodes, how can they work? I think I put it in a right way. I'm putting a lot of chemicals, they are not working. How EPNs you claim that it will work?
Yeah. So for this, we need to understand the functioning of chemicals. So chemicals function in a way that it will kill directly on contact with the contact or systemic. Yeah. So over a period of time, what happens is these pests develop a resistance to those chemicals. Those chemicals are foreign bodies. We've synthesized them. So they will be able to create resistance to a foreign object. But if you consider entomopathogenic nematodes, as I said, they have been present in the soil from time immemorial. They are a part of nature. So they come under the predator-prey mechanism.
Okay.
So where there is a prey,
there is a predator. Wonderful.
The predator is
Samuel Prince.
Okay. Coined by. There are people who coined that.
I'll ask my farmers to put it back if there's something or other. Where there is a prey, there is a predator. Okay.
Where there is a way, there is a will. Exactly.
Yeah. Okay.
So this mechanism will never fail. As long as the earth functions, this mechanism will never fail.
Okay.
A prey cannot develop resistance to a predator.
Okay.
Yeah, we know that.
Yeah, we know that.
Similarly, in nature, that possibility is zero.
Okay, this is one part.
Yeah, this is one point. Second one, when we are applying chemicals, it sustains in the top layer of the soil. So the pest may be in the bottom layer of soil.
No, I can't say only first layer. It may or
may not. But there are the possibilities of it sustaining in the top layer is higher. So what if the pest is below those top layer in a range of 10 to 15 centimeters?
So you mean to say that during dormancy or anything, the pest goes
They
inside.
can go down, right? So that during that time, the application of chemicals would prove as a negative result.
Can I ask, because during the rodent management session I was having with Dr. Shaktivel sir in NIPHM, he said that the rats can sense the poison and they might run away. Similarly, when insecticides are being applied, can insects feel it and safeguard themselves by going deep inside the soil?
There have been no results for that, no papers or no studies for that at present.
Because if it happens, if insects can sense their danger to safeguard themselves, then whatever you explain next.
But then the total concept of pesticide application would fail.
Will not work.
Yeah.
Okay, so now please continue.
Then, once they go down, the contact will be reduced.
Okay.
So, but in case of EPN, it will go in search of moisture. So moisture may be in the top layer of soil, that is in the 3 to 5 centimeter range or the 10 to 15 centimeter range.
Okay.
So once it goes in search of moisture, there you will find the prey. So directly it will attack the prey. So the possibility of contact, the possibility of higher efficiency increases for you. So that is the difference between chemical and entomopathogenic nematode application.
So can I put it that chemicals are security guard and EPNs are police? Security will only protect if someone comes to us. But EPNs can go search of it.
Yeah.
Okay. Wonderful. Okay. So it was a wonderful discussion. Mind blowing.
Thank you.
I hope it reaches more people and more people start adapting EPNs and you grow in that, we grow in that, because this is an holistic approach. We are giving to Mother Nature what we took from her. So that is a wonderful, all thanks to ICAR first, our mother institute, and all thanks to SBI, all thanks to TNAU, all thanks to NBIR, and all thanks to you in the end. So now can we summarize? Can you just summarize everything so that we can, or you want me to summarize? So how it goes?
I would like to know what is your take
Oh
on
my
this.
God, you are putting me in a complicated position. Okay. So what I understood.
So now the roles have reversed.
Yeah, roles have reversed. No, it's always good to be on this side, man. Okay. So there are so many new learnings I have been, because you have been with me for more than a year. You shared me a lot of knowledge which I don't think I might have got into textbooks or something. So in this short term, what I have understood is EPNs are not advisable as a solo practice because using it in a solo practice and spoiling the name of this particular organism is also a bad thing. Use it in an integrated approach. It is recommended in an integrated pest management approach, and it is highly recommendable during flowering phases where there are instances of cross pollination. And the biggest another thing which I was very happy that if I put it in the soil, I can make myself rest assured that at least whatever this Steinonema glacieri and Heterorhabdis indica take care, my product is safe, my produce is safe from the predator, from the plant parasitic things. So that is one part I have learned. And the other part is like there are so many things, but in the foliar applications it gave wonderful results. So that was new thing, so I can adapt this as an alternative. So our adaptation was like, if I go for an organophosphate spray, next I'll go for gut poisoning spray, then I'll go for what we call pyrethroids, and I was rotating like this. Now your aspect is making me think in such a way that I should advise an organophosphate first, then or else I will go for first an neem oil. Then if there are certain things, I'll go for EPN. Agar un dono mein bhi in those two things it is not getting controlled, then I might go for chemical. So my ETL level ko you have given a wing. My ETL level will wait more now. So that my MRL levels will come down.
Yes.
So wonderful. So these are the takeaways. I hope that I have understood something and I made justice to the whatever knowledge you have given to me, because rest assured, I can promise you that this knowledge will reach many people, especially the farmers of Bidar will be educated in a proper way. Our team is committed to do that. And thanks for reaching us out on a call, because you have traveled so far to Bidar, and you will be always privileged to have people like you. I expect more such topics will happen and we can educate farmers. And the biggest challenge is I have to decode this entire conversation in the local language. I don't have the resources yet, and if someone can help me, that is wonderful thing. So let us see how it goes. So words won't suffice you to thank, because you have put your 2.5 to 3 years of experience in just couple of hours conversation. I don't think many people who are entrepreneurs will trade their trade secrets, but I can see that you have openly explained everything, whatever you were talking and all those things. So I'm so glad to have such people in like I call it in Tamil as in our Kannada we call it as Mandina Maga, the son of soil. So you are another son of soil, an unsung hero, I'll tell you, because you are being supportive to farmers, and not only that, you have made your entrepreneurial journey in such a way that you will also grow along with plenty of farmers, and you are making justice to the soil. So I think you might have buttered so much. I have buttered you so much. So it's really, I meant it. So it was a good conversation. Thank you so much for being a privileged guest.
Yeah,
thank you.
I would also like to thank you for giving this opportunity to reach out to so many farmers.
Yeah.
Your platform over the past 1 year, my experience with you has been growing in knowledge every single time.
Yeah.
My inputs and your outputs that you've been giving me, I've been growing, so that I have got negative inputs also from you,
yes,
if we could remember.
Yeah.
So that has been a learning process for both of us.
Yes.
Both our institutions have been learning through that.
Yes.
And I would like to take the chance to tell to your viewers also, or the farmers who are viewing it, if there is a need for entomopathogenic nematode based control in and around Karnataka, I would say the best source of reaching would be through Bidar Horticulture Farmer Producer Company. They have a wide extension of support, and they provide ground level data, which in turn comes to us. And these data turn out to be the difference between a normal application and a connected mode of application. So I hope I was also as helpful to you as you
it
were
was
to me.
because there are people who give solutions, who sell solutions. You are not selling solution. The outstanding part was you were approaching me. You were not about, you have passed me one shipment. When is the next shipment? You were never asked. You are, how did the previous shipment work? Do you have any ground data? And I want to explain here. You are here to get those soil samples where we applied EPN and to check that and how did it work. So yes, on ending note, we have buttered each other so much.
So there is a future pipeline project coming with our FPO here.
Yes.
We would want to discuss it on a bigger
work
platform.
On an optimistic way. And I would be glad to thank our Department of Horticulture who has placed me in here, and because it has given me wings, and that has given me courage to speak about being a guy from different genre. It has given me wings to talk our KVK, our Horticulture College, our University of Agriculture Science Raichur, which is Bagalkot. There are so many people. And NIPHM, I'll never forget, because there I have never shared on this platform about my journey. I think you might be asking me questions and I'll answer on that part. So let us see, because you have made us so much comfortable. So NIPHM, Indian Institute of Spice Research, and how can I miss it? Indian Institute of Horticulture Research. My mother institution for all this knowledge. So it's been wonderful talking to you. I hope we'll have further talks on this EPNs. So guys, for any requirement on EPNs, the numbers will be provided down. Please call EPN man, Mr. Samuel Prince. He is always available. So we are available for you for ground data, for critique, or we work on a process where we want feedbacks on that, and we are ready to get the feedbacks, either it is negative or positive, and we'll give more importance to the feedbacks, and we'll make sure we'll work on that particular product and make and rejuvenate our soil again. So it's signing off, Chetan Dabke. Thank you.